Hello, ladies and gentlemen. Today we're going to look at a problem involving sliding blocks attached with pulleys on an inclined plane. Let's get started by reading the question together. Figure shows a system of pulleys comprising two blocks of equal mass on a frictionless inclined plane. What is the acceleration of the block residing on the inclined plane when the masses are let go and allowed to move freely? So we get started by identifying the forces that are acting on the blocks and pulley. Let's start with this mass, with this block, because it's the simplest one. So the forces that are acting on this are its weight, which is pulling it down, and the tension force exerted by this rope 1 that's pulling it up. What about the second block? Well, before we write down the forces, let's define the direction along the inclined plane to be x direction and the direction perpendicular to be y direction. Just like this, right? So this is our x direction and this is our y direction. Now the forces acting on this block are its weight pointing straight down, tension force exerted by the second rope, which is pulling the block up along the inclined surface, and the normal force exerted by the inclined surface on the block, which is up along the y direction. Now, you notice that normal force and the tension force are along y and x direction respectively. The odd man here is weight, which is neither along x or y direction, right? So what we have to do, we have to represent this weight through its x and y components. So if this angle is given as 37 degrees, then this angle is going to be 53. Why is that? Because notice that this angle is 90 degrees, right? And this is 37. So internal angle of triangles is 180. So that means this should be 90 minus 37, which is 53 degrees. And since angle between x and y directions is 90 degrees and this is 53, then this must be 90 minus 53, which is again 37 degrees. Now, so what we're gonna do is we're just gonna draw x and y components of the weight, and we will express them through this angle. So you might ask, why cosine 37 and why sine 37? Well, it's straightforward. So think this as a right triangle, right? So this is a hypotenuse, this is an adjacent leg, and if I translate this to this side, this is going to be opposite leg. So sine of an angle, or in this case sine of 37, is defined as opposite side of a right triangle divided by its hypotenuse, which is this, right? So opposite side would be x component of the weight divided by actual weight, mg. So sine 37 equals wx divided by mg, or wx equals mg times sine 37. Similarly, for y component, this is the adjacent leg of the right triangle. That means adjacent leg divided by hypotenuse have to give us a cosine of this angle, or cosine of 37, or wy in this case is going to be mg times cosine 37. Okay, so one thing we should note before we start writing down the forces for this pulley is the tension along the ropes. Since this rope is continuous, tension everywhere on this rope is going to be the same. So tension here, here, or here is equal to T1. Similarly, for this second rope, tension is going to be the same everywhere. So it's going to be T2 here, T2 here, T2 here, T2 here, right? Because ropes are continuous and tension everywhere on the rope must be the same. Otherwise, rope is going to break. Well, so what are the forces acting on this pulley? Well, T1, tension exerted by the rope 1, is pulling it up, and two forces that are pulling it down are going to be T2 and T2, right? Because you have a tension exerted from two sides of the pulley. So that's it. That are all the forces we need to solve this problem. But before we go further, I just want to make a quick comment about the normal force. So in this case, normal force and the y component of the weight of the second block are equal to each other. Why is that? Because block is not moving along y direction. So if block is not moving along y direction, these forces are balanced. So Wy has to be equal to normal force. The reason I'm mentioning it because this is not really relevant to this problem, and we're not going to talk about it after this point, but it becomes relevant if you have to deal with the friction forces, because friction force actually involves normal force. So next thing we're going to do, we're going to start writing down the equations of motions for the blocks and pulley. Let's start by this block, okay? So before we do that, let's define the direction of motion. I'm just gonna make a guess, and I'm gonna assume that block moves in this direction. So you will see later that it really doesn't matter if our assumption is right or wrong. It's just to define the forces and direction of motion and acceleration. So we're gonna choose this direction, to be our direction of motion. In that case, what's going to happen is net force on the first block is going to be equal its weight, which is a bigger force because it's pulling it down, minus the tension force, right? So this is our net force. And according to Newton's second law, the net force has to be equal to mass times acceleration. Now, using mg instead of w, we end up with this equation, and from here we can easily obtain that tension in the first rope is equals to mass times g minus a. Well, let's look at the second block. Well, second block, similarly, we've already established that the block is not going to move along y direction, so we're not going to talk about it. But the motion is going to be primarily along the inclined plane, right? So along this x direction that we defined earlier. So since this block is moving down, that means this block is going to be moving up. So tension 2 must be greater than the x component of the weight that's pulling the block down. So what is the net force then? Well, it's going to be tension force minus x component of the weight equals mass times the acceleration of the block. And note that the acceleration of this block is twice the acceleration of this first block. Why is that? Imagine that this block slides down by 1 meter, right? So your displacement for the first block is 1 meter. That means this pulley will get pulled up by 1 meter. If this pulley gets pulled up by 1 meter, this side of the rope that's attached to the wall has to extend by 1 meter. And this extension will come at the expense of this side. So this side will shrink. As pulley moves up, this side gets shorter by 1 meter, this side gets longer by 1 meter. So this block will slide because of that by 1 meter. But also note that the whole pulley moved up by 1 meter. So the second block will move up by 1 plus 1 meter, which is 2 meters, right? So for example, now if you're going to consider just a particular time interval, when this block moves by 1 meter in a particular time interval, this block will move by 2 meters. So it's not only its displacement, but also its velocity is going to go up by 2. So if its velocity increases by 2, then the rate of change of velocity in a particular amount of time is also going to be twice here than that is here, okay? So acceleration is also going to be a factor of 2 greater than the acceleration here. That's why we have 2a, with a being the acceleration of the first block. So here we're going to do the same thing. Instead of wx, we're going to write down mg times sine 37, and we solve for the t2, which is equal to then m times 0.6g plus 2a. 0.6 comes from sine 37, right? Sine 37 is roughly 0.6. Now I'm going to write down the equation for this pulley. Well, net force acting on a pulley is T1 minus 2 T2s, because pulley is moving in this direction, right? And note that pulley is massless, right? So this pulley in this problem, the mass of the pulley is negligible. So we're going to assume the mass of the pulley to be 0. So net force is T1 minus 2 T2s equals to mass times acceleration according to the Newton's second law. Well, mass is 0, which means T1 must be equal to twice the T2. Well, now we have this equation. What we're going to do, we know T1, we know T2, so we just plug them in here and we get this equation. So for T1 we have m times g minus a equals 2 times T2, which is m times 0.6 g plus 2a. Cancel m from both sides. That's what we're going to end up with. And if we solve this equation, by moving a's to one side and g's to the other side, we end up with 3a equals minus 0.2 g, or a equals minus g over 15. Now, note that there is a minus sign, right? So what does it tell me? My acceleration is negative. So my original choice for the acceleration, which I assume to be upward, is wrong. So my block is actually my original acceleration, which I choose to be downward, is wrong. So my acceleration in fact is the acceleration pointing up, right? So that's what minus sign tells me. So our choice that block is moving down was wrong. So that's all. So even if we made a wrong assumption, we still know in which direction the block is accelerating. Right? So block is accelerating in upward direction, which means everything is moving down the inclined plane. Is this the answer? No, because the question is asking what is the acceleration of the block residing on the inclined plane. So they're asking for the acceleration of this block, and we know that this acceleration is twice the acceleration of the first block, right? Here we established that, and I explained you why. So the acceleration of the second block is going to be twice this acceleration, which is going to be minus 2g divided by 15, or minus 1.33 meters per second square. Again, minus sign just tells us instead of moving up, it's just sliding down. But numerical value, or the magnitude of the acceleration, is 1.33 meters per second square. And that's the answer for this question. I hope everything is clear, and I thank you for your time.